811 part 2 video. Again, you should definitely have watched the preview video, and you should definitely have watched the 811 part 1 video, or at least understand what was in those. So on this one, it starts with 8.2. In problem 1, we constructed several special segments, an isosceles right triangle. What special triangles can you construct? Choose at least 3 of these. I would do this as a warm-up. I would say just go ahead and go either use a real compass and a straight edge, or go over to a website like this and see what you can figure out. But we did it as a warm-up and discussed it briefly in class. So now we jump to a problem like 8.3, which again, 8.3 doesn't show up on this resource page. So 8.2 and 8.3 don't show up on this resource page. But what we're asked to do is we're asked to make a centroid. And a centroid it's the point of balance where medians meet. So you can see this kid has this triangle over here and a pencil on the triangle, where the centroid is the part where if you put your pencil there, it like perfectly weighs a triangle, which is kind of weird because triangles have like this, interesting shape. So the idea that there's a point of balance on it is kind of weird, but the idea is it's actually where the medians meet. So I'm just going to go ahead here and I'm going to just make a regular triangle, and we are going to do the medians. And if you remember, the medians are the point between the opposite vertex and the middle of the opposite side. So I need to essentially do the perpendicular bisector of all 3 sides, and that way I can get that point in the middle, and then I can extend it across. And once I have that, I am going to have the perpendicular, I will have the, centroid. A lot going on right now, sorry. Okay, so again, I'm going to kind of go with different colors. So I think I'll do one in gray, one in blue, one in red, and then I guess I'll make it in green. I don't know. So let's go ahead and, again, the first thing I'm doing, I didn't like that. I thought I chose gray. Okay. Now I have gray. So let's, okay. So I'm going to go here. I will move this along here. Oh, you can see I barely made that long enough. Not very good on my part. So long story short, there's my perpendicular bisector of this side. So I'm going to go back to black now, and I'm going to take this and I'm going to move this across. So there we go. That is one of my medians. Now I will go ahead and change colors and make another median. So I'll make a median for this one over here. Uh-oh, you can see I left this arc short over here. There we go. And now this point, if I extend a point from here to the opposite vertex, I will have another median. So I want to point something out here. I've only done 2 medians, but you can see these 2 already meet. So it better work out that when I do the median here, that it also crosses that point, because I already know where the centroid is. I already know that this point is the center of balance just because I did it on 2 sides. I'm going to confirm that using the 3rd side again, but if it doesn't work out, then I got a real problem here. So I'm going to go ahead, I'm going to make this thing a little bit bigger just in case. Remember, it's got to be more than halfway, so I want to make sure it's at least halfway. So we'll go across here, and again, I'll connect this to get my perpendicular bisector. So if I extend from this point across, and again, I just want to be real clear about this. When I go from this vertex to this point, it had better go through that middle right there. And you can see it does. So that point right there is known as the centroid. If I cut this triangle out and put a pencil lead right there, it would balance that triangle. That would be the center of balance, which I think is kind of cool. So that is one of the things we're looking at. You definitely need to know what a centroid is. You need to know what a median is, all that good stuff. So make sure you're keeping track of this. Now we will jump down to 8.4. 8-4 asks us to get the circumcenter of a triangle, and the circumcenter is where the perpendicular bisectors meet. So real similar to what we just did with the centroid, but just slightly different. So I'll show you what I mean by that. So we're just going to have a triangle, and what I need to do here is I need to get the perpendicular bisectors again. So you might be thinking, well, geez, this is like exactly what we just did, but it's actually not exactly like we just did. It's slightly different. So I'll show you what I mean by that. We're gonna go over here. We're gonna make these arcs so we can get the perpendicular bisector. I don't know, I'll just go the whole way across. That way it's fine. Uh-oh. You can see how much I'm struggling to get the thing there. Okay, so there we go. Now, here's the thing. On the other one, we found the point and we went to the opposite vertex. But on this one, we're not gonna. We're just gonna actually go all the way across with our perpendicular bisector. And it's kind of unfortunate here. I don't know if I can extend this thing exactly, but there we go. So we've extended that perpendicular bisector all the way across. It just so happened that for whatever reason it went through this vertex. I just got lucky there. That wasn't by plan, if you're wondering. Okay, so let's go ahead and make another perpendicular bisector. So we'll go over here, and we'll go over here. And I think you'll see what I was talking about. On this one, it doesn't actually go through the opposite vertice. So there we go. I already have, I guess I should have used black for these ones like I did on the last one, but I already have my point right here. This is already the circumcenter, and I mean, it has some pretty cool properties, and I'll show you what those are in a bit, but let's go ahead and finish this up. And again, just like we did on the last one, this thing has to work, if I did it correctly, where when I combine this one as well, this should go straight through. So let's see. It should go straight through the point I already have. So you can see, there we go, where those three meet is my circumcenter. So now here's what's so cool about a circumcenter, at least in my opinion. And by the way, I hope you caught the difference between the medians and the perpendicular bisectors. The medians, we got this point and then went opposite to the opposite vertex. That would have been the median, but we just went straight through with that perpendicular bisector. But here's the thing. If I can go to the circumcenter and count that as the middle, and then I move this length so that it hits a point, what happens is, when I make the circle go all the way around, you can see it hits all the points. So what I've done here is I found the point where I can make a circle go all the way exactly outside of the triangle. So kind of neat. That circumcenter is exactly the point, again, that makes you be able to put a circle around the outside of the triangle. And then the next one we're going to do is the in-center, and I'm guessing that you can guess what the in-center is. The in-center is going to be the point where the angle bisectors meet, which is important because it's where you can inscribe a circle on a triangle. So let's go ahead and get our triangle, and then we will do the angle bisectors. And again, we're going to come up with something I think is pretty cool after we've done that. So I'll change the colors here. Let's get these angle bisectors. So there we go. I hate when it goes off like that. It's so frustrating. Okay, there we go. So there we go. And I guess I'll do this one in black. So here we go. Here's one angle bisector. Now I will go ahead and I will do another angle bisector. Again, I guess I'll do this one in black. And just like we talked about in the previous last couple things we've done, I already have the in-center now. I already know that this point right here is the in-center, but I'll do the angle bisector for this last angle, and again, it has to go through this point, otherwise I've screwed something up. So let's go ahead and use this color this time. So let's get one more angle bisector. This one's gonna be kind of a pain. There we go. So get this angle bisector. This might not be wide enough. Let's see if it'll meet. Oh, it does meet. Lucky me. Okay, so we will get this angle bisector. And again, you'll see it does go straight through that point. And again, it better go through that point. Now, what's kind of cool about this is, and this one's a little bit trickier to do, I think. But if we go here, and I don't know, let's pick, I don't know, is orange going to be noticeable? I'm not sure. Purple, maybe? Maybe green. Green might be a good choice. So I'm going to go ahead and I'm going to put my compass on, the end of my compass on the in-center point. And now what I'm going to do is I'm going to make this thing, and this is where it gets a little bit tricky, but I want to get it to the smallest point I can where it actually hits the triangle. And now if I did this correctly, and I draw this circle going all the way around, I have what is known as the in-center. So it's the exact opposite of the circumcenter, right? The circumcenter, we had a circle going around the outside of the triangle. The in-center is the point where you can draw a circle that goes inside. So again, some kind of cool things here. I think we had the centroid at the beginning, which was the balance. That was the center of balance. That's where the medians met. Then we did the circumcenter. That was where we could draw a circle around the outside of the triangle, and that was where the perpendicular bisectors met. And now we have the in-center. The in-center is the point where you can draw a circle that goes inside the triangle, and that is where the angle bisectors meet. So some pretty cool stuff in this lesson. Again, I think the people who figured this stuff out are amazing. I think they deserve a lot of credit. And all right, that is that for that video.